And welcome back. Good morning, good evening, and if you're watching this on a recorded version as opposed to live, perhaps good afternoon. Welcome to Grockit's OGTV GMAT edition. We're going through that 12th edition of the guide right there, like it says in the lower left-hand side of your screen. My name's Jim Jacobson, like it says in the upper right-hand side of the screen. That's me smiling at you because this is fun to do, kind of. You're watching Grockit. So each session we go through a certain number of questions. It seems like it's about 14, and so that's why it's scheduled out, at least for the problem, for the data sufficiency section. So last time we left off with we finished with question number 141 on page 285. We're nearing the end of the data sufficiency section. So this time we will pick up, still on page 285, with question number 142. And as always, if you've been watching this broadcast, you hear me say this every single time for data sufficiency, so sorry about that. Plug your ears or go get a drink of water while I say this. But I write down the reminders of what each answer choice stands for. The first one is that statement 1 is sufficient. The second one is that statement 2 is sufficient. The third one is that together they are sufficient but individually insufficient. The fourth one is that either one is sufficient on its own. And then the last one is that neither one is sufficient even in conjunction with the other one. So without further ado, number 142. So what amount did Jean earn from the commission on her sales in the first half of 1988? First half of 1988. That's kind of a while ago. So in order to solve for this, and it is always a good idea to get a rough idea of what type of information in the statements would give you sufficiency. So in order to know the amount she earned from the commission on her sales, we would need to know the sales and what her commission rate is. And it would need to be for the first half of 1988. Or we would need to be able to derive that information from the information that we were given. But we need to be able to get to those two things for this time period. Let's see what the statements give us. So statement 1 tells us in 1988, Jean's commission was 5% of the total amount of her sales. So the commission is 5%. However, we are given no information about the sales to which we should apply that 5% commission. So on its own, statement 1 is not sufficient. That eliminates answer choices A and D because both of those require statement 1 to be sufficient. Statement 2. The amount of Jean's sales in the second half of 1988 averaged $10,000 more per month than in the first half. Well, so this tells us a little bit. It tells us that the second half of 1988, so if she averaged $10,000 per month, she got $60,000 more in sales in the second half. But this doesn't give us the commission rate. And more importantly, it also doesn't give us the sales for the first half of 1988. It does give us that it's $60,000 less total, but we still don't get the information that we need. So it's insufficient. So it's not B. The only thing left is to look at the two together. So with the two together, we do have her commission rate, and we know that she earned an additional $60,000 in the second half of 1988. However, we still don't know how much she actually earned in the first half of 1988, so we have no solid number to apply this commission rate of 5% to. So even together, the two statements are not sufficient. Excuse me, a little bit of a cold. Answer choice E, neither one is sufficient, even together. Last one on page 285. Question number 142. No, 143. Whoops. So the price per share of stock X increased by 10% over the same time period that the price per share of stock Y decreased by 10%. The reduced price per share of stock Y was what percent of the original price per share of stock X? So we know stock X plus 10%, stock Y minus 10%. And what the question is actually asking for is the fraction or the percent that the reduced value of stock Y is of the original value of stock X. And so the reduced value of Y, since it went down 10%, it's 90% of its original price. So, and since stock X went up 10%, its original value is just the value of X. So this question is asking for 0.9 Y over X. So if we can actually solve for Y over X, we can multiply that times 0.9 and we will have our answer. That's a Y. There, maybe that's easier. Okay. Let's see what we get. Statement 1. The increased price per share of stock Y was equal to the original price per... the increased price per share of stock X was equal to the original price per share of stock Y. So the increased price of stock X is the one that went up 10%. So that's 110% of X is equal to the original price per share of stock Y. That's plain old Y. So from there, we can just divide both sides, or actually what we could do is we could just substitute, we have Y equals 1.1x. This could be substituted into our equation here. So then it would just be a value for X, and we could solve. We would be able to solve for Y over X. So statement 1 is sufficient. We can cross off answer choices B, C, and E. All of those require statement 1 to be insufficient. Statement 2. The increase in the price per share of stock X was 10/11ths the decrease in the price per share of stock Y. So the amount that stock X went up was 10%. That is to say, 0.1x. That was equal to 10/11ths of the decrease in the price per share of stock Y. And of course, stock Y went down 10%. So that is also 0.1 Y. And again, because we have the two variables in a single equation, we could get all the variables on one side, or we could get Y over X on one side. We would divide both sides by X, and then divide both sides by all the other numbers on this side. And we could get ourselves to Y over X just as easily and multiply that times 0.9. So again, this one also allows us to get to Y over X. Like in this case, this one, Y over X, would have equaled 1.10, because we divided both sides by X. This one I don't want to do the math because it looks like it would take more steps, but we could do the same thing to get Y and X on the same side of the equation. So either statement on its own is sufficient. That's answer choice D. I think I originally said that you could substitute Y in place of X here. We wouldn't want to do that. We would want to solve for what Y over X equals. So sorry for the confusion. In both cases, we get the desired relationship of the two variables from the statements, and then that gives us the percentile that we're after in the original question. Turning the page to page 286, number 144. So in the figure above, if the area of triangular region D is 4, what is the length of a side of square region A? Excuse me, I'm sorry. So triangular region D shall be this. That's pretty good. So we have a right angle, a D, an A, a B, and a C. The area of triangular region D is 4. Remember that the area of a triangle is 1/2 the base times the height, equals the area. So in this particular case, 1/2 the base times the height of triangle D equals 4, which means that the base times the height equals 8. If we can figure out either one of the base or the height, we can figure out the other one because, the one times the other equals 8. And then with two of the sides of the triangle, namely this side and this side, the base and the height, we could use those two to figure out via the Pythagorean theorem what the third side is, and that would actually be the desired side of square A. So the base or the height of triangle D gets us what we want, as does other information about square A itself. Let's see what we get in the statements. Statement 1 tells us the area of square region B is 9. Area of B equals 9. Now it does tell us that it's a square, so that means that the side length of B is the square root of 9. So one of the sides of B, I probably shouldn't have used B because that looks like the base of the triangle. The side of capital B equals 3. But that is also the height of the triangle. So now we have the base times the height, which is 3, equals 8. Therefore, the base equals 8/3. And from there, we can figure out what the side of square region A is. We would take, 3 squared plus 8/3 squared equals C squared, and then go from there. I don't want to, but we could. Because then it's simply math. C would be the square root of those two things together. So statement 1 is sufficient. We can cross off B, C, or E. Statement 2. The area of square region C is 64/9. And again, so the side of C would be the square root of 64/9, which equals 8/3. Again, that's a good sign. That's what we had actually determined that the base equaled from the information we were given in statement 1. We can't use the information that we had in statement 1 to determine sufficiency, but we can use it to determine whether we're on the right track. Remember, they're not going to have you the problems are internally consistent. That is to say, if statement 1 tells you that the base is 8/3, a sufficient statement for statement 2 will not give you some other number for the base. So knowing that we came up with the same one tells us that we were on the right track. Anyway, statement 2 also sufficient because it gives us the base, and using the exact same calculation, we would have been able to determine that the height was 3, and then we would get to this equation 2, and once we found whatever C is, that would be the side of square A, which is what the question was asking for. So it is not A, which required statement 2 to be insufficient, but D, which says either statement is sufficient. Okay, page 286. Question 145. If Sarah's age is exactly twice Bill's age, what is Sarah's age? So we have S equals 2B, and the question is asking what S equals. If we're given either the value of either of these variables or a second distinct equation that we can use to substitute in here, we will have sufficiency. So let's see what we get. Statement 1, 4 years ago, Sarah's age was exactly 3 times Bill's age. So 4 years ago, S minus 4 would also equal So her age was 3 times Bill's age 4 years ago. So that simplifies to, S equals 3b minus 8. And so in this case, we could substitute this value, or we could substitute this value up here in for S. We would have 2b equals 3b minus 8. Subtract a b and add an 8 to both sides, we get b equals 8. And we know that S equals 2b, so S equals 16. So again, we would never actually want to do this math unless we lacked confidence on the real GMAT. Just know that getting a second unique equation for our two variables is sufficient, but I just wanted to show that it came out reasonable. Sarah doesn't turn out to be 375 years old. And yeah, so we have sufficiency. Statement 1 is sufficient for us to have our answer, which eliminates B, C, and E. Statement 2, 8 years from now, Sarah's age will be exactly 1.5 times Bill's age. So Sarah in 8 years will be 1.5 times Bill's age. Again, Bill's age in 8 years. The modifying phrase 8 years from now tells us, and as it did the 4 years ago in statement 1, by having that modifying phrase at the beginning, it tells us that both of their ages need to be incremented by 8. Had it been, Sarah's age 8 years from now will be 1.5 times Bill's age now, it would be an entirely different story. But since both of these are 8 years from now, we increment both variables by 8. This one comes out to be the same thing. We would multiply all of this out. It would be, S plus 8 equals 1.5, B plus 12, and then, again, we can substitute S equals 2B. We get it down to a single variable, and we would be able to solve for B, which would turn out to be the same thing because these problems are internally consistent. So it is either statement that is sufficient, and answer choice D is the one that's correct. Again, with two variables, you need two distinct equations when you need to solve for a single one of the variables. Page 286, number 146. A report consisting of 2,600 words is divided into 23 paragraphs. A 2-paragraph preface is then added to the report. Is the average or arithmetic mean number of words per paragraph for all 25 paragraphs less than 120? So, what it's actually asking is, so if the average of 25 paragraphs is less than 120 words per paragraph, 25 times 120, that equals 3,000. So what it's saying is, is the whole thing, what is it, a paper? It's a report. The whole report less than 3,000 words. But we actually have a little bit of additional information about this one. We knew that the report was 2,600 words before they added the 2-paragraph preface. So, 3,000 minus the 2,600 words before they added those 2 paragraphs equals 400. So the question is really asking, is the preface less than 400 words? If it is, the whole report is less than 3,000 words and the average per paragraph is less than 120. If the 2 paragraphs of the preface combine to be more than if they end up, it should be less than or equal to. If it's more than 400 words, then the whole report is not under 3,000 words, and therefore not under 120 words per paragraph. Statements, give us your information. So statement 1 tells us each paragraph of the preface has more than 100 words. Well, each paragraph greater than 100 words. Which means the preface itself, since it's 2 paragraphs long, is greater than 200 words. However, knowing that the preface is greater than 200 words does not tell us for sure whether it's less than or equal to 400 words. Again, it could be 201 words. It could be 1,000 words, 2 500-word paragraphs. That's terrible writing, by the way. 500 words is like 2 pages. You wouldn't want to have a 2-page paragraph. So, but of course, you know, we're not in the world of writing, we're in the world of math. Anyway, it's not sufficient because we don't have an upper limit on the value of these paragraphs or the preface, and we need an upper limit to determine sufficiency. So statement 1 is insufficient. It's not B and it's not D. Oh, excuse me, it's not A and it's not D. It could still be B. Statement 2 tells us that each paragraph of the preface has fewer than 150 words. So each paragraph fewer than 150 words, which means that the whole preface is less than 300 words because it's a 2-paragraph preface. And remember, we were asking, is the preface less than or equal to 400 words? If the preface is less or contains, fewer, sorry. If the preface contains fewer than 300 words, I probably should be more precise in my language, since less versus fewer is something that will show up on the verbal side. The preface contains fewer than 300 words. It definitely contains fewer than 400 words. So that tells us that statement 2 is sufficient to tell us that the whole report is under 3,000 and the average per paragraph is under 120 words per paragraph. So it was, in fact, statement 2 and answer choice B rather than C or E. Page 286, question 147. So a certain bookcase has 2 shelves of books. On the upper shelf, the book with the greatest number of pages has 400 pages. On the lower shelf, the book with the least number of pages has 475 pages. What is the median number of pages for all of the books on the 2 shelves? Wow. So we'll create our imaginary bookshelf fairly simply for now. So every book, so the book with the greatest number of pages has 400. There are other, A, B, C, D. However many books leading up to 400, they are all less than 400, equal to or less than 400. So 400 is the biggest book on the top shelf. We also know that on the bottom shelf, the least number of pages is 475. So the smallest book, these are in ascending order, by the way. Let's see, let's start with M, N, O, P, Q. And we don't know how many books there are there, but 475 is the smallest one. So the question is, what is the median number of pages for all of the books on the 2 shelves? And remember, the median number, when you have an even number of values in your set, it's the average of the middle 2. When you have an odd number of numbers in your set, it is just the middle value. So basically, from our set here, we need to determine how many books are on each shelf, because then we can figure out perhaps what these middle values are. So statement 1 tells us there are 25 books on the upper shelf. So that gives us 25 on the upper. But without knowing how many books are on the bottom shelf, we will have no idea, what the median value is. So this can't possibly be sufficient. It's not A and it's not D. We have to pretend like we didn't know that. Statement 2 tells us that the bottom shelf has 24 books. So that gives us a 24 down here, but without the upper shelf, it can't be sufficient. We can't determine the middle number in the numbers. So it's not B. The two together, we have both values, 25 on the upper shelf and 24 on the lower shelf. So if we were to imagine all of the books in a row in terms of their number of pages, we have 25 books here and 24 books on the lower shelf. 25 plus 24 is 49, which is an odd number. That means that the median will be one of the actual books on the shelf instead of an average of two of them. And it's going to be the middle number. The middle number between 25 and 24 is the 25th book right here. Book number 25 on the upper shelf. And since these are done in ascending order, the lowest number of pages will be, A, B, C, D, all the way up to whatever this one is. The 25th book will be the book with the most pages on the top shelf, which we have established from the original problem is 400. The 25th book is the biggest book on the top shelf. I mean, some other books before it may also have 400 pages, but the middle value in our set is one of the ones with the largest page count on the top shelf, i.e. the 400-page book. So the two statements together are sufficient. They actually point right to answer choice C. Together, the two statements are sufficient. Tricky. So page 286, question number 148. The figure above shows the number of meters in the lengths of the four sides of a jogging path. What is the total distance around the path? Draw the path over here. X plus 60, and 3x. The total would equal those four things together. 3x plus x plus x plus x plus 60 equals 6x plus 60. So if we can solve for x, we can figure out the perimeter of the figure. Statement 1 tells us one of the sides of the path is 120 meters long. It's pretty clear that that's not going to be sufficient for us because we have no idea which of these sides is the 120. If x is the 120, and of course, I mean, there's a 50% chance that that it's 120 because two of the sides are x, but it could just as easily be the x plus 60 or the 3x. So without knowing which side is x, knowing that one side is 120 can't be sufficient. So it's not A and it's not D. Second statement. One of the sides of the path is twice as long as each of the two shortest sides. Okay, so this looks promising. First, in terms of figuring out what the shortest sides are, we have two sides that are x. Well, first off, we only have two sides that are the same value. And so clearly x is the shortest side because one of these other sides is 3 times that and one of the other sides is 60 more than that. So one side is twice x. One side equals 2x. And our only two choices are x plus 60 and 3x. we can't possibly have 3x equal 2x. That doesn't make sense. So it must be that x plus 60 equals 2x, which means that x itself equals 60, and there we have sufficiency. Once we have x, we can plug that value into 6x plus 60. So statement 2 is sufficient, crossing off C and E. Answer choice B is the correct one. Excuse me. Okay, let's see, number 149. 286, number 149. In the rectangular coordinate system above, if OP is less than PQ, is the area of region OPQ greater than 48? Now this one, it is very important to have a picture. Okay. O, P, and Q. So we also know that OP is greater than PQ, and is OPQ greater than 48 is what they want to know. Okay, so we don't have any other information. Remember that the area of OPQ would be 1/2 the base times the height. So if we can determine the base and the height, we can determine whether it is greater than 48. So statement 1 over here gives us that the coordinates of point P are 6 and 8. So point P is 6, 8, which means we have an imaginary point down here. We'll put our imaginary lines in green. So this is 6, 0. Which means that the height of half of the triangle is 8, and the base of half of the triangle is 6. So the area of this half of the triangle, this guy here, and clearly it's a 3, 4, 5 triangle because these are each multiples of 3 and 4, so this must be a multiple of 5. So the base is 2 times 3, the height is 2 times 4, and so the hypotenuse will be 2 times 5, which is 10. We don't need the hypotenuse to figure out the area, but it's good to just kind of have that out there. So the area of this half, 1/2 the base times the base times the height is 48. 1/2 of that is 24. So the area of that half is 24. But we also know that OP is greater than PQ. So this length here is greater than 10. The height of the triangle is going to stay the same. And if the hypotenuse is greater and the height is the same, the base must be greater. So the area of this side of the triangle is going to be greater than 24 because the base has to be longer than 6. And that's enough for us to answer the question because the area of triangle OPQ is going to be 24 plus something greater than 24. It's going to be something equals something greater than 48, which is what the question was asking. So statement 1, by telling us that P is 6 and 8, that is sufficient. We can cross off answer choices B, C, and E. Statement 2 tells us that the coordinates of point P are 13 and 0. Q. Q is 13 and 0. And I already drew all over my diagram here, but hopefully it's clear. Actually, I'll make it a little bit clearer. We have no idea anymore where P is, nor any of the sides of the triangle. We just have this. And what this tells us is that OQ basically is 13. But without knowing anything about the height of the triangle, there's no way we can determine the area. Point P could be, 10 or 7. We can't look at it and just kind of eyeball it and say, well, clearly the height is this. So without knowing the height of the triangle, we can't determine the area, so we can't actually answer the question. Statement 2 is insufficient. We can cross off D and choose A. Okay. Page 286, question number 150. In the expression above, if x times n does not equal 0, what is the value of s? So we have xn does not equal 0, s equals what? And the reason why we have x times n does not equal 0, that means neither x nor n can be 0, and we can see why they did that. That's because both x and n are denominators of fractions within the expression for s. So this basically just eliminates the possibility of dividing by 0, which is nice of them, because that would be undefined. So we have this monstrous expression, s equals 2 over n over 1 over x plus 2 over 3x. And since we're trying to solve for s here, your first instinct might be to multiply both sides of the equation by the denominator of this fraction. But since we're going to have to get s on its own anyway, the question is asking what is the value of s. It's better to try and just leave it and try and simplify the fraction on its own on this side. So the way to do that is to get rid of the denominators of all of these fractions by multiplying the numerator and the denominator of the mega fraction by the common denominator of the smaller fractions. So each of them has as its common denominator 3xn. So if we multiply the fraction times 3xn over 3xn, any number over itself equals 1. But then we get rid of the denominators in the fractions. So if you multiply 3xn times 2 over n, you end up with 6xn over n. And then we end up with 3xn over x plus 6xn over 3x. And then you can start simplifying each of those fractions to eliminate the denominators. So then we end up with, in the numerator, 6x, because the n's cancel out. And then the x's cancel out, we get 3n. And on the second fraction, 6 over 3 ends up being 2, and the x's cancel out, 2n. So that equals 6x over 5n, or s equals 6/5 times x over n. Forgot an equals there. So if we can solve for x over n, we can solve for s. Let's see what the statements give us. Statement 1 gives us x equals 2n. Well, if we divide both sides by n, we get x over n equals 2, and we could just substitute this value directly into this, and we would be able to solve for s. So that is sufficient. Statement, and we can cross off B, C, and E. Statement 2 gives us n equals 1/2. Well, that would be useful, but we don't have x. Remember, we're dealing with an equation with two variables here. This guy here is an equation with two variables. We need both of them. So knowing that n equals 1/2 is not quite enough, we would still need x. No x, no sufficiency, so we can cross off D and circle A. on kind of a macro level, the way this question is constructed is very like a reading comprehension passage where the passage itself is very challenging, very hard to read, where you have to do a lot of figuring and concentrating to get to kind of figure out what the essence of the passage is. But then once you do, the questions are very easy. That's one strategy they use in giving you these questions, giving you something that's challenging to process, but then once you do, the questions themselves are easy. The alternative is to, of course, give you something easy to process and then give you difficult questions. Or choose medium of each. Remember that a statistically significant number of you need to be able to get every question right and every question wrong, or the questions they come up with are no good to an admissions office. They could make a test that almost nobody could get right, or they could make a test that everyone would get right, but then the scores wouldn't differentiate anybody, and MBA admissions programs would start looking for another test. So, last one on page 286, which is number 151. If n is a positive integer and k equals 51 times 10 to the n power, what is the value of k? So k equals 5 point, did I say 51? I meant 5.1 times 10. Maybe I just thought I said 51 because it's question number 151. In any case, really the value of k is 5.1 times 10 to the n, and n is a positive number. With questions like this, it really is easy just to figure out what some of the values for the real number could be. So if n is positive, it can't be 0, so we're not dealing with, n equals 1, 2, 3, 4, that's probably enough. So if it's 5.1 times 10 to the first, it's going to be 51, 510. Basically just add a 0 every time. Let's do 10 to the fifth. Sure, why not? We'll do 10 to the sixth. Good enough. So the question is, what is the value of k? In order to know what k is, we need to know what n is. And if we know what n is, we can use that chart. So statement 1 tells us that k itself is greater than 6,000 and less than 500,000. Well, this chart that we just came up with for k is going to help us a lot here. K is greater than 6,000, so that rules out this number, anything below this. And it's also less than 500,000, which rules out the 510,000 value. So here, clearly, k equals 51,000, because that's the only positive integer value for n that gives you a value for k in the range specified. So here, k equals 51,000 because n is 4. Statement 1 is sufficient. It's not B, C, or E. Statement 2, k squared equals 2.601 times 10 to the 9th. Wow, okay. So to solve for k, we would just take the square root of both sides. So the square root of k squared equals the square root of 2.601 times 10 to the 9th. So clearly this is going to be k equals, and remember, the square root of a times b equals the square root of a times the square root of b. So we can separate out the two elements of the scientific notation. So that's the square root of 2. Well, no, let's not do that first. First, let's get rid of the decimal. So 2.601 times 10 to the 9th is the same thing as 2,601 times 10 to the 6th. Basically, the 3 decimal places that we needed to move it to get rid of the decimal, we take out of the exponent. So let's do k equals the square root of 2,601 times the square root of 10 to the 6th. Hopefully you all were able to follow my logic there. There's a step in here where we converted this to that. So the square root of 10 to the 6th is pretty easy. That's going to be 10 to the 3rd. The big problem is this square root of 2,601. You look at that and you say, ugh, that's terrible. But really, the question, it can only really be one thing. The question is 2,601 divisible by 51 on some level? So, because all of our answers are 5.1 or 51, so just divide 2601 by 51. If it comes out to be an even multiple, then we're set and the question is sufficient. If it's not, then it's not. I mean, it should be, but, we'll see. So, 51 goes into 265 times. That ends up being 251. 255. No wonder that's wrong. Okay, so, so then it ends up being 51. Okay, so we find out that 2,600, maybe this was obvious to you, but 2601 is 51 squared. So the square root of 2601 is just 51. And so 51 times 10 to the 3rd is the same thing as 5.1 times 10 to the 4th, which is what we already knew. And we also knew that, we didn't have to figure that out, but 51 times 10 to the 3rd equals 51,000. Statement 2 is also sufficient. It's answer choice D. On to the next page, page 287, question number 152. If Carmen had 12 more tapes, she would have twice as many tapes as Raphael. Does Carmen have fewer tapes than Raphael? So we know that C plus 12 equals 2R. If she had 12 more, she would have twice as many as Raphael. That alone isn't enough to tell us anything. For example, if we assume that Raphael, so we have each of these, if we assume that he has 20, she would have 28, and then adding 12, she would have twice as many. If we pick really small numbers, if Raphael has, let's say, 7, in order to get, that means that Carmen currently has 2, and with 12 more tapes, she would have twice as many. So the question is, does Carmen have fewer tapes than Raphael? Really, what's going on here is they break even at 12. If Raphael equals 12 and Carmen equals 12, then they have the same number. So the question is ultimately asking, does Raphael or Carmen have fewer than 12 tapes? If one of them has fewer than 12, Carmen has fewer than Raphael. If one of them is more than 12, then Carmen has more tapes than Raphael. So is R greater than 12 or is C greater than 12? Statement 1, Raphael has more than 5 tapes. R is greater than 5, but what we needed to know is R greater than 12? So knowing that R is greater than 5 gives us, actually it gives us either one of these scenarios that we dreamed up, just to kind of illustrate our point. So, and since the answer is, the question was, does Carmen have fewer tapes? And the answer is no in the first column and yes in the second column. This is clearly insufficient. It's not A or D. Statement 2 tells us that Carmen has fewer than 12 tapes. C is less than 12. If Carmen has fewer than 12, then Carmen does have fewer than Raphael. In every case, when Carmen equaled 12, then they had the same number of tapes. If she has fewer than 12, he has more than her, and therefore the answer is yes, Carmen has fewer tapes than Raphael. So statement 2 is sufficient. We can eliminate C and E and circle B. All right, 287, question number 153. If x is an integer, is x times the absolute value of x less than 2? And basically that would be true given if x were a fraction or if x were negative. So let's find out what we get. So first one, x is less than 0. If x is less than 0, x times the absolute value of x would be a negative number times a positive number, which would automatically be less than 2. So therefore statement 1 is sufficient. We can cross off B, C, and E. Statement 2 tells us that x equals negative 10, and that's exactly the same thing. X is a negative number, the absolute value of x is positive, that also will be less than 2. So either one is sufficient. It is answer choice D. It's a relatively easy one, as long as you realize that how to do absolute value, which is to make it a positive number. Okay. So 287, number 154. If n is a positive integer, is the value of b minus a at least twice the value of 3 to the n minus 2 to the n? Yikes. Is b minus a greater than or equal to 2 times 3 to the n minus 2 to the n? Well, nothing we can do without looking at some statements. We have a equals 2 to the n plus 1, and b equals 3 to the n plus 1. So it turns out that this is actually pretty helpful. So b minus a will be 3 to the n plus 1 minus 2 to the n plus 1. And remember that, let's say, x to the a times x to the b equals x to the a plus b. So 3 to the n plus 1 is the same thing as 3 to the n times 3 to the 1 minus, same thing with 2, 2 to the n times 2 to the 1, which is just 2. And we can actually compare that to the original question. So is b minus a this thing? So is 3 times 3 to the n minus 2 times 2 to the n, is that, what's the relationship of that? Is it greater than or equal to 2 times 3 to the n minus 2 times 2 to the n? You may be wondering where I got that. That is just this right here. Remember, the question was asking us, is it more than, or is it at least twice the value of 3 to the n, is it at least twice the value of 3 to the n minus 2 to the n? So we just distributed the 2 over each of those elements. So 2 times 3 to the n is less than 3 times 3 to the n. So whatever number this ends up being, this is going to be a bigger number because we have a larger number in the first part and the same part that we're subtracting. So statement 1 is actually enough to tell us, yes, b minus a, once we were given values for b minus a, in terms of the original 3 to the n minus 2 to the n, b minus a is at least, and is basically greater than 3 to the n minus 2 to the n. So statement 1 is sufficient. We can get rid of b, c, and e. Statement 2, all we find out is that n equals 3. There's no way we could figure out anything from n equals 3. Well, we could figure out what 3 to the n minus 2 to the n equals and what 2 times that equals, but without a and b, we have nothing. No a, no b. We can't answer the question, so statement 2 is insufficient. It's not D. It is answer choice A. All right, one more problem. Page 287, number 155. The inflation index for the year 1989 relative to the year 1970 was 3.56. indicating that on the average, for each dollar spent in 1970 for goods, $3.56 had to be spent for the same goods in 1989. If the price of a Model K mixer increased precisely according to the inflation index, what was the price of the mixer in 1970? So, we have 2 years. We have 1970 and 1989. Every dollar spent in 1970 was $3.56 in 1989, according to the inflation index. And of course, that's an average, but we find out that the Model K mixer increased exactly according to this inflation index. So that means, for every dollar spent in 1970, you spent an additional $2.56 in 1989. Now, in order to figure out, what was the price of the mixer in 1970, we need to know the price in 1989, basically. Or if they just want to give us outright the value for the price of the mixer in 1970 or in some convoluted way, that would also be sufficient. But my prediction is we're going to need the price in 1989. So statement 1. The price of the Model K mixer was $102.40 more in 1989 than in 1970. So, 1989 minus 1970. This is the price. Equals 102.40. Which tells us that basically the inflation index accounted for an increase of 102.40. So for every dollar spent in 1970, they spent an additional $2.56. So this is basically it's $2.56 times the 1970 price. Equals 102.40. So we could divide both sides by $2.56, and actually it turns out that the 1970 price equals $40. So statement 1 is sufficient. So we can cross off B, C, and E. Statement 2 tells us that the price of the Model K mixer was $142.40 in 1989. Price in 1989 equals $142.40, so we can set up a proportion. For every $1 in 1970, it was $3.56 in 1989. The price in 1970, we don't know what it was, but we do know what it was in 1989. We solve for x, and of course x is going to equal $40 this way too. So statement 2 is also sufficient. I was going to make that a dollar sign. Too many dollar signs in this question. Anyway, so either one is sufficient on its own, so answer choice D is the correct one. We'll stop there. That's a good place to stop because that was another 14 questions. Next time we will pick up on page 287 with number 156. Again, my name's Jim Jacobson. You've been watching the Grockit.com OGTV program where we go through, in this particular case, the 12th edition of the guide to the GMAT question by question, cover to cover. Tune in next time. What is today anyway? Today is the 18th. So yes, there's quite a few more broadcasts. There will be a couple days that we won't be broadcasting because of the holidays. I have other places that I have to go. But aside from those days, I will be with you through into the new year. So see you next time.